This is an overview video for College Trigonometry version 3 by Stitz and Ziegler, 10.5 Graphs of the Trigonometric Functions. This video covers the graphs of the secant and cosecant functions. When looking at the basic graph of the secant function, recall that secant x is 1 over cosine x. So we're looking at the cosine value on this unit circle, the 1. So 1 over 1 is 1, 0, 1. That's our first key point. Secant cosine's 1, secant's 1. Here we have pi halves, cosine 0. Secant 1 over 0 is undefined. So at pi halves, secant's undefined. This will be a vertical asymptote at pi halves. Moving along, at pi, cosine's -1, so secant's also -1. At 3 pi halves, cosine is 0, secant will be undefined. Again, we have a vertical asymptote. And finally, at 2 pi, cosine's 1, 1 over 1 is 1. So these key points, that one, and that one, give us these points here. And then the divide by zeros, the undefines, these give us our vertical asymptotes. Now you might see the cosine wave. Oops, I didn't actually want to do it. Now it's not going to let me delete it. Okay, back to laser. Here we go. You might see the cosine wave in books like this, and it'll always be dashed. The secant, because it's 1 over cosine, does the opposite. So cosine alternates between -1 and +1. Secant stays out of -1 to +1, so it goes off towards infinity. Looks like parabolas perhaps, but these are not parabolas because of the vertical asymptotes. There's a different shape. Now this will go on forever. There will be a piece up here, then a piece down here, then a piece up here, then a piece down there. With asymptotes, we can take a look. The asymptote goes from pi halves to 3 pi halves. That would be pi. So every pi is an asymptote in the general secant function. What we're looking at here is one period, one cycle, and the period's actually 2 pi. The period will be twice as long as the asymptote distance for secant, and you'll see for cosecant as well. A similar story happens when you look at the graph of cosecant. Cosecant is 1 over sine x. So you look at the sine values. So we have 0, 0, pi halves 1, pi 0, 3 pi halves -1. So you'll see these here. 0, 0, pi halves 1, pi 0, 3 pi halves -1, and finally 2 pi and 0. These are the 5 key points for the sine. If you flip those, 1 over x, 1 over 0 is undefined. So we have a vertical asymptote right at 0. 1 over 1 is 1. 1 over pi, or 1 over 0 at pi is undefined, another vertical asymptote. 1 over -1 is -1. And undefined again, divide by 0. You will see the sine wave inside where the old sine wave was, and make sure you dash this if you use it at all. Don't have it a solid line. Where the old sine was at its baseline, you now have vertical asymptotes for the reciprocal cosecant. And where the old sine was at its amplitude, that's where the new reciprocal cosecant takes off towards the infinities. If the sine was up, it goes up. If the sine was at its down part, the cosecant goes down. The period of cosecant is 2 pi, and the distance between asymptotes would be half of that, pi. Great. To summarize the properties of secant and cosecant, you have this table. First off, the domain, everywhere for secant, everywhere cosine is 0, secant's going to have a vertical asymptote. So the domain will be all those values except for those vertical asymptotes. It can be written in this union notation for the domain. The range is outside of the normal range for cosine, so from negative infinity to negative 1, and then from 1 to infinity. It is continuous and smooth on its domain. However, it's not continuous and smooth everywhere because the domain is broken up with vertical asymptotes. It's an even function, just like cosine was even, secant is even. Period's 2 pi, just like cosine. Cosecant has a similar story. It's odd like sine, and its period is also like sine with 2 pi. Secant has vertical asymptotes at the pi halves because cosine equals 0 at the pi halves, and cosecant has vertical asymptotes at the pi's because sine equals 0 at the pi's. A specific example illustrates the basic concept that this book uses. So the 5 key x values for the sine wave, which is also for the cosecant and the cosine and the secant, all the same here. You set the inside of your trig function equal to those values. Solve for x gives you new x values. You then plug those 5 new x values into the function using your unit circle or other methods to evaluate, and you get either undefineds or values. The undefineds are your vertical asymptotes, and the values give you the takeoff points. In this case, we can see from negative 1 to positive 1, the period of this one would be 2. All right, that completes these graphs.